So hi everyone, this is Dr. Z. Ravindranath working as Assistant Professor of Mathematics in MLR Institute of Technology. So in this video, we are going to discuss what is interpolation concept. In that interpolation concept, we are going to discuss what is a Newton's forward interpolation, and we'll take some problems on the Newton's forward interpolation. So let us take. So first we'll explain Newton's forward interpolation, where we can use this Newton's forward interpolation in the concept of finite differences here. So now let us take one example here. So I have taken the function y is equal to f of x. Y is equal to f of x. So now I have given a data of x and y values. So x values, y values 0, 1, 2, 3, 4. Now its corresponding values are 0, 3, 5, 7 and 10. So this is the data here given and the function is unknown function. Now I ask you to find out the value of y at x is equal to 0.5. So this is the x value, x is equal to 0.5. At this value of x, I want to get the value of y. X is equal to 0.5, it is not mentioned in the problem, in the table. So for that value, in the table he has given only x is equal to 0, x is equal to 1, 2, 3, 4. And at this corresponding values of y as given as 0, 3, 5, 7 and 10. Now this x is equal to 0.5. At this point, I want to find out the value of y for unknown function y is equal to f of x. Then we have to take the help of this Newton's forward interpolation. So now we'll see why we have to apply this Newton's forward interpolation concept here. Why don't you go for this next backward differences? Now I'll explain here. So x is equal to 0.5. So that lies between 0 and 1. So in between this 0 and 1 we have 0.5 and this 0.5 lies at the beginning of the table here. So whenever the x value lies at the beginning of the table, at that particular point of x, if you want to find out the value of y, then we will go for the Newton's forward interpolation formula. So whenever we want to apply this Newton's forward interpolation formula, the difference between the values of x must have a common difference. 0 and 1. If you take the first two values, the difference is 1. If you take the next two values 1 and 2, the difference is 1. If you take the next 2 and 3 values, the difference is 1. So like this, the values between the values of x must have a common difference. That common difference we can say that step length. That step length is represented with h. So this, whenever we are having these type of x values, then we can say that the values, x values are equally spaced, or we can say that the x values having the same common difference. Okay, so the difference is 1. So in this case, whenever that x value lies at the beginning of the table, then at that particular value of x, if you want to find out the value of y, then we can use the concept of Newton's forward interpolation. So now this is as a standard formula of Newton's forward interpolation. So y of x is equal to y naught del p into delta y naught plus p into p minus 1 by 2 factorial into delta square y naught and p into p minus 1 into p minus 2 by 3 factorial into delta cube y naught. And we can continue these terms here. Is the number of terms in that standard formula, it depends upon the difference table once again. So this y naught value, delta y naught value, delta square y naught value, delta cube y naught value, on these values we can get these values in the forward difference table. And now here the unknown value is p value here. So in order to find out that p value, we have the standard formula, that is x minus x naught by h. X is nothing but the point where you are going to find out the value of y, that will be given in the problem. And x naught is nothing but the initial value of x which is given in the data, and h is the common difference between the values of x. So by substituting all this x value, x naught value and h value here in this formula, then we can get our p value. Now substitute these p values and all the remaining values from the table, then we can get our required value of y at the given particular value of x. This is the standard form of Newton's forward interpolation. Now let us take one example here, how we can find out this y, how we can apply this Newton's forward interpolation here. So here some data has given. The data is related to the population of sub 10 town here. And now estimate the population for the year 1895. So this is the data in the 1891. The total population of the town is 46,000. In the year 1901, the population of that particular town is 66,000. So like this, for every 10 years, he has given the data of that population of that town here. Now, I want to find out the population of that town in the year 1895. This 1895, this year is not mentioned in this one table. Okay. Now, in this year, I want to get the population of that particular town. Now, once if you observe this, so we can consider this we can consider this 1895 as x value. At this x value, we have to get the value of y. That y is represented with population. Okay, this is our problem. Now here, I want to check whether this x is equal to 1895 lies at the beginning of the table or not. So once if you observe this one, 1895, that lies between 1891 and 1901. So since this 1895 lies at the beginning of the table, so if you want to find out the value of y at x is equal to 1895, then we can use the concept of Newton's forward interpolation. And once if you observe the difference between these values of x, 1891, 1901, the difference is 10. And if you take 1901 and 1911, the difference is 10. And if you take 1911 and 1921, the difference is 10. So like this, for all the values of x, we are having a common difference, that is 10. We can consider that 10 as step size or common difference, that is represented with h is equal to h value. That h we can consider as 10. Now this is x value, and we have to find out that y value or this particular value of x. And this from the table, it is very clear that h is equal to, h is nothing but a common difference, as given as 10. Now, in order to apply this Newton's forward interpolation, we have to consider the initial value, that the values of x are represented with the standard format. The first value is represented with x1 and the second value is represented with x1, x0. First value is represented with x0, second value is represented with x1. And the third value is represented with x2, and the next value is represented with x3 and x4. So we don't want this x1, x2, x3 and x4. You concentrate only on x0. We can use this x0 value to find out the value of p. So that p is equal to, we have the formula x minus x0 by h. So x is the given value 1895, and x0, the first value of x in the table, that is 1891 by difference, that is 10. So if we simplify this, we will get our p value here. Now let us, so here we have taken, so 1895 lies at the beginning of the table. Already we have discussed, so we have to use Newton's forward interpolation formula. So we consider the initial value x0 with 1891. So now we'll find out the value of p here. So we got p is equal to x minus x0 by h, which is value is given by 0.4. Now p value is 0.4. Now we are ready to construct the forward difference table here. Now, as we discussed in the previous videos, and we have seen how to construct the forward difference table for the given data, follow the same procedure here. Take the values of x and take the y values here which are given in the table. So represent this y value as y0 and the second value of y as y1, so y2, y3 and y4. Now as usual, find out the difference between these two. you will get the difference of these two values is 20, which is represented with the delta y0, and take the difference of this y2 and y1, the difference is 15, so you represent that value as delta y1. Take next y2 and y3, the difference is 12, take this one as delta y2. So next difference is 8, so 101 minus 93, you will get the difference value as 8, so represented with delta y3. So this is the values of first forward differences, which is represented with the delta y. And now you once again you find out the differences of these values in the next column. So 15 minus 20, you will get minus 5, which is represented with the delta square y0. And the next two values, the difference is minus 3, so you may get negative values also, no need to worry about this. And 8 minus 12 minus 4, this is represented with the delta square y2. Next, go for the next third forward differences of y by taking these two numbers, minus 3 minus of minus 5, you will get 2, which is represented with the delta cube y0. And similarly the next one is delta cube y1. So next find out the difference of these two numbers, you will get minus 3, which is represented with the delta power 4 y0. So now we got a single value in that particular column, fourth forward difference column. Now we can stop our forward difference table here. Now whatever the values we got in the forward difference table, we will use only these first values in that columns in the Newton's forward interpolation: y0, delta y0, delta square y0, delta cube y0, and delta power 4. We will use these values in the forward difference table here in the Newton's forward interpolation formula. Now we will take the forward interpolation formula. So here, once if you observe this table here, we have stopped the table, forward difference table, at delta power 4. That is fourth forward differences. Now in the Newton's forward interpolation formula, so we can take up to delta power 4 term. So that's why I have taken this interpolation formula up to delta power 4 y0, because we got only up to this value. So now we got that p value, you substitute that p value. In the forward difference table, we got y0 is equal to 46. If we calculate, we got that p value is equal to 0.4, and delta y0 we got that value as 20 in the forward difference table. So like this, you substitute all the values here in the Newton's forward interpolation formula. So you will get like this. Now simplify this. So finally we will get our required y value here. So in the year 1895, the population of the town is 54.45 thousands. So this is the way how we can find out that particular value of y at a particular given value of x by using Newton's forward interpolation formula. Now let us take one more example here. So in the previous problem, he has given the table directly. Now here in this problem, he has given that individual values, and by using these values we have to construct the table data, and then we have to go to the forward difference table, and then we can use our Newton's forward interpolation formula. So the difference between this problem and the previous problem is, in the previous problem he has given the data in the tabular column, and here he has given the data individually. That is the main difference between the two problems. Okay, so here apply the Newton's. In the problem itself he has mentioned the Newton's forward interpolation formula. Now by using this Newton's forward interpolation formula, our task is finding the value of root over 5.5. In order to find out this root over 5.5, he has given some data. He has given root 5 is equal to something, and root 6 he has given the value, root 7, root 8. Now this is the data given in the problem. We have to use these values, root 7, root 5, root 6, root 7, root 8, and by using this data we have to get the value of root over 5.5 using Newton's forward interpolation. Okay, so here the common function is root over root. So we have taken the whatever the values we are having under the root in the given data, I have considered that root that values as a x values, and whatever the values we have got after equal to RHS side, I have considered that values as y. So x values are given in the data is 5, 6, 7, and its corresponding y values, the root 5. So if you substitute x is equal to 5 here, you will get y is equal to root 5. That value is given by 2.236, and similarly root x value, this is the value, root 7 we have taken here, root 8. So this is the way how we can convert this data into the tabular column. So once after converting into a table, then as usual, as we discussed in the previous problem, we have to construct that forward difference table here. And similarly, so if you want to find out this, if you want to apply this Newton's forward interpolation, we have to get the value of p. So now the p value, so this is, so here x value is as given as 5.5. For this 5.5 we have to get the root over value here. So you consider that x as 5.5, and this 5.5 lies between 5 and 6, so which lies at the beginning of the table. So since our x value lies at the beginning of the table, so we can use Newton's forward interpolation formula. So now in general we can represent this x values as x0, next value of x as x1, x2, and this is x3 here. So our x0 value, now it is very clear that x0 is x0 is 5. So 5.5 minus 5, you will get this p value is equal to 0.5. Now construct this forward difference table here. Now find out these values. So we can take, so these are the values of x and these are the values of y. Now find out the difference of this. So 2.449 minus 2.236, you will get this value is equal to, so 0.213. Now find out these values, next pair. So second value, that is 2.646 minus 2.449. So you will get this value is equal to 0.197. Now next you take these two values here, 2.828 minus 2.646. Here you will get this value is equal to 0.182. And similarly take the next two pair values. In the next second, go for the differences of this first forward differences and get the values in the second forward differences of y, that is delta square. So 0.197 minus 0.213, you will get this value is equal to minus 0.016, and take the next, so 0.182 minus 0.197, you will get this value is equal to minus 0.015. Next you take the differences of this, minus 0.015, minus of minus, it becomes plus 0.016. You will get this value is equal to 0.001. So this is our Newton's forward interpolation formula. So now similarly you substitute this y0 value, p value, delta y0 value. So in each and every term you substitute its corresponding values and simplify this. So you will get that value is equal to, that is y of x is nothing but root over 5.5. You will get this, we got this value is equal to 2.345. This is our final value here. So next problem is how to find out the Newton's forward interpolating polynomial. Whenever in the problem if they ask you to find out the interpolating polynomial, Newton's forward interpolating polynomial for the given data. So in the previous problems they have given some x values. At that x values we have seen how to find out its corresponding y value. That is one model. And if you go for the next model, so in the next model we have to find out the Newton's forward interpolating polynomial. So whenever they ask you to find out the polynomial, In the problem, they will not give the x value here. You keep that x as it is and we have to get the value of y in terms of x. That is, we have to get the relation between these two variables. Okay, now this is the data. X is equal to 0, 1, 2, 3, 0, these corresponding y values. Now find out the value of p here. So x value, he has not given x value in the problem. So whenever he asks to find out the polynomial, so no need to substitute anything for x. You keep that x as it is. And this, as we discussed in the earlier, this x naught value is equal to 0. So we have taken x naught equal to 0. Now we got p is equal to 0. Okay. Now as usual, construct the forward difference table. This is our forward difference table for the given values of y. So here 1, 2, 3 we have seen how to construct this forward difference table. Follow the same procedure and construct the forward difference table here. So in the forward difference table, this is the highest column, that is third forward differences of y. Okay. So whenever in any difference of y, if you get 0, while you are taking this Newton's forward interpolation, we can neglect this delta cube y term and we can stop the formula up to delta square y. So Newton's forward interpolation formula is given by, so that's why I have not taken, since here that third forward differences of y we got 0, so that's why I have not taken this delta cube y term here. I have stopped up to delta square y. So this is our Newton's forward interpolation formula. Substitute x naught value, this is our x naught value, and then in the second term delta y naught value is given by 2, and in the third term delta square y naught value, so up to this one delta square y naught value has given as 2. So this is only take up to delta square y naught up to this point. Okay, now substitute these values here. So y naught is 1 and put p is equal to x, delta y naught we got that value is equal to 2, x minus 1 by 2 factorial, and delta square y naught we got that value is equal to 2. Now simplify this. Once if you simplify this, we will get this value, y value in terms of x. This is our required polynomial, 1 plus x square. So in the problem, sometimes after finding that polynomial, they ask you to find out y value at x is equal to something. Suppose if they have given x is equal to 3, after finding the polynomial, if they ask you to evaluate the value of y at x is equal to 3, then here you substitute that x value here in the polynomial, x is equal to 3. So x is equal to 3 plus 3 squared, that is 9. So you will get y is equal to 13. So like this also they will ask in the examinations. After finding the polynomial, by using that polynomial, find the value of y at x is equal to some value you will mention in the problem. So then after finding the polynomial, you substitute that x value given in the problem. Here in that polynomial you will get our required y value here. So this is the way how we can find out this polynomial. Now in this video we have discussed when we can use this Newton's forward interpolation formula, and we have seen how to use this Newton's forward interpolation formula to find out the value of y at a given values of x. We have taken some examples on the Newton's forward interpolation. Now in the next video we will go for the Newton's backward interpolation. So before going to discuss about the Newton's backward interpolation, first we will see what is backward differences, how to construct the backward difference table, and then we will go for the Newton's backward interpolation formula. Thank you for watching.